So today we are going to discuss the commonly known ideas regarding the magnetism. The first point we can discuss about the earth magnetism. Suppose consider this is an earth. This is an earth. The geography north pole is here. The geographic south pole is here because earth is spinning about its axis every 24 hours. So the one rotation it will take for complete revolution, that will for spinning revolution, that will be 24 hours. The time period of the spinning is 24 hours. So this is a geometric north as well as the south pole. Suppose if you are taking that, you can just draw the diagram. You can connect the geometric north and pole. Suppose if you are taking the earth, if you are considered as a magnet, what is the north and south pole of the earth magnet? Because earth is spinning. If it is spinning, so there is a lava inside, it is circulating, it will generate the current, because lava is made up of electrons, the charged particle. Once the charged particle making the circular loop, if it is spinning, then it will generate the magnetic fields. So that magnetic field, it will be looking like that. But the earth south pole of the magnet is near the north pole of geographic north pole. Earth north magnetic north pole near to the geographic south pole, but it never coincide with each other. So the earth magnetic field line start from the geographic south, then end up to the geographic north. Or else another way you can say, the earth south pole, it is geographic south pole, the magnetic field lines are starting and ending to the geographic north pole. So because if you are consider the bar magnet, the magnetic field lines always starting from the north pole and then ending to the south pole, but it will form a closed loop. So it can go inside also, so but it never intersects, so it will form a closed loop. So this is a thing basically understanding we have to know. Now suppose if you are keeping one bar magnet here in the along the earth magnetic field, so if you are keeping it here, what it would happen, it will point north as well as the south pole of the magnet. This magnet will have the north pole as well as the south pole. The bar magnet, if you are suspending, so the suspension bar magnet north pole pointing the south magnetic earth magnetic pole, the south pole of the bar magnet pointing the north earth magnetic pole. Or else another way you can say, the suspended bar magnet north pole pointing the geographic north pole, the bar magnet south pole is pointing south geographic pole. Why it is pointing like that, we will know, because the like poles are repulsive each other, the unlike poles are attractive each other. Here earth magnetic south pole, here north pole, it will attract. Here south pole of the bar magnet, here north magnetic pole, so it will attract each other. That's why the bar magnet is pointing opposite to the earth magnetic poles. This is the first point we got to understand. The next point, there is a repulsive force when the north poles of the two magnets are brought close together. Suppose if you are bringing the two bar magnet, if this is a north pole, if this is a north pole, this is south pole, this is south pole, is north will repel each other, then you will feel the repulsive force between this north pole. Suppose if you are bringing other way, take the two bar magnet, put the north pole here nearest to the south pole of the other magnet, so it will attract each other. So there is a repulsive force between the between the north pole. There is a attractive force, but between the unlike poles, the north as well as the south. That's why here the suspended magnet north is pointing towards the south magnetic earth magnetic pole. The third thing we want to understand, once if you are breaking the magnet, suppose if you are taking the bigger magnet, if this is the north pole, this is the south pole, if you are put the hammer here, or somehow if you break it into two pieces, what would happen? Here again it will form the small magnet, that means north south. Here it will form the north south. So even if you are breaking, you can't separate the north pole alone, south pole alone. So if you are breaking one single magnet into two pieces, so again it will form the small tiny magnet. That means you can't separate the single pole in magnetism. You can't separate single pole in magnet. That means there is no monopole like electrostatic. There is no monopole. Monopole means it's a single pole. There is no single north pole, there is no single south pole occurring in nature. So if you see the electrostatic, even if you just take the neutral atom, there is a equal number of electron, equal number of proton. So if you are just knock out one electron, it will become positive charges. Suppose if you are adding one electron, if you are knock out one electron, it will become positive charges. If you are adding one electron, so it will become negative charges in the electrostatic. This is the case. Removing the electron, it will create the more positive charge in the it will feel the more positive charge in the neutral atom, it will become positive. That means single positive charge you can form in the electrostatic. In the similar manner, you can, if you are adding one electron there, so it will become negative charge. That means single negative pole you can form in the electrostatic. But in the magnetostatic, you can't separate single north pole as well as a single south pole. The last point we have to understand for in the regarding that magnetism means it is possible to make the magnet out of the iron and its alloys. So ions is a good magnet, because why it is ions are using to form the magnet, or manufacture using ions and its alloys means, because iron have a lot of 3D electrons. The valence electron, I think it would be 4 valence electron it is having the iron. So this valence electron, each and the electron spin contribution will be more. So 4 spin contribution, 4 valence electron, 4 unpaired electron, that will contribute more magnetism. That's why we are using the iron for creating the magnets.